Okay, these are some more problems from section 5.4, I'm sorry, 9.4, section 9.4, where we're trying to find the radius of convergence for the power series. And if we look at this power series, it's the summation from n equals 0 to infinity of negative 1 to the n 4x plus 1 to the n. We can combine these and we can get a ratio of negative 4x plus 1. So this is a geometric series. And again, we could put them both under the n and we would have negative 4x plus 1 to the n. So that's definitely a geometric series. And that converges for r is less than 1. So this is my r, and of the absolute value that's less than 1. We take the absolute value of 1, absolute value of this, we can just separate the negative sign and take the absolute value of negative, which is positive. We have this. So this is less than 1. Now my radius of convergence is not 1 because if you look over on theorem 5 on page 504, it has to be in this form: x minus a is less than r, not 4x. So we've got to get rid of the 4x to figure out the radius of convergence. Okay? So what we're going to have to do is we'll kind of rewrite it like this, and then we'll factor the 4 out. And this is going to change my center. My a is going to be negative 1/4, but we're not interested in that right now. We're just interested in the radius of convergence. So I just have to make this into a single x. So I'll factor the 4 out, and I have 4, and then the absolute value of 4 is just 4. So I could still set this less than 1. And then if I divide both sides by 4, I have the absolute value of x plus 1/4 is less than 1/4. I divide both sides by 4. And then I could put it in between negative 1/4 and 1/4 if I want, but this is really what I want. I just want this radius convergence. So r is going to be 1/4. Now later we'll talk about this, but the actual center of this will be negative 1/4. And we'll talk about the interval of convergence later. But for right now, this is what we want. So we just have to have it in this form. Okay? And then number 10, we're going to use the ratio test. This is the first one we get to do the ratio test on. Because this is not geometric, we can't get a common ratio because this is not n to the n. So this n is going to be changing. This is going to go by factors of n. So we're just going to have to use the ratio test. It's just a unique type series. So we'll use that. So we'll just remember the ratio test. We're going to take the limit of a sub n plus 1 over a sub n. So that's going to be the limit. And then a sub n plus 1, this is going to be 3x minus 2 to the n plus 1 over n plus 1 divided by by a to the n, or I'll just invert and multiply. So I'll put the n on top, and this goes on the bottom. And these are all absolute values. Now I don't need the absolute value on my n terms because those are always positive, so I'll just put the absolute value on the 3x minus 2 terms or factors. Okay? Now we can combine these. Well, first of all, we can rewrite this, and this is what I did. This is 3x minus 2 to the n plus, or times 3x minus 2 to the first, all right? So I'm just kind of showing how we can simplify this. Okay? So I just broke that up. So you can see that I've got 3n minus 2 to the n, 3n minus 2 to the first, and if we multiply those, we would add those. So this is the same as this. And then we've got the 3n minus 2 to the n, so you can see that these are cancel. So I put the n over the n plus 1 in front, and then I have just left the 3x minus 2, which was from this. Now, when I take the limit as n approaches infinity, because that's what we're doing for the ratio test, we're taking the limit. Okay, as I take the limit of this, there's no n's involved here, so I just have to deal with this factor. And if I take the limit, remember n over n plus 1, there's all kinds of ways to do this, but the limit of this is going to be 1. You could substitute infinity, you could look at the ratio of the highest degree terms, which is 1 over 1, the ratio of the coefficients, and that's 1. Or you could break it up into 1 plus 1 over n. Okay, this would be 1. Well, I guess we can break it up like that. Sorry, that wouldn't work. We would just have to take it the other way. Okay. We can't break that up. If it was reversed, we could. So we would think of it as just the other way. If we could look at the ratio of the terms, or we can just say that this is like that, so it's infinity over infinity. Still 1. Either way, it's 1. Lots of ways to get that to be 1. So this is going to end up being this. All right. So that's my simplification of this, and we know that this is my L. Okay, that equals L. And we know that converges when L is less than 1. Right? Remember, converges. When L is less than 1. Okay, from the ratio test. Okay, so we just set that less than 1, and that's when it converges. Now again, we're in the same boat as we were in the last problem. We don't want a 3 in front, so we have to get the 3 out, because it has to be in the form x minus something. So if I factor the x out, if I divide 2 by 3, because I'm factoring a 3 out, I divide this by 3, I get x. If I divide this by 3, I get 2/3. So I got 3 times x minus 2/3 is less than 1. So that's my center is going to be 2/3, but I'm not worried about that. I'm just worried about the radius of convergence. So I'll divide both sides by 3, and this is what I have. So my radius of convergence is 1/3. Okay. So I hope you can see all this in here. You can always zoom in, I think, and see what's going on with that. I can zoom in a little bit. And you can see how we kind of manipulated that. And that's a standard technique we're going to be using in these ratio tests. Okay? So I hope that helps.